Hello everyone, welcome to Reliability Insider channel. We share practical reliability knowledge from insider's view. Today's reliability topic is Weibull Lifetime. I will explain to you what it really means, how to interpret it, and how to use it for benchmarking reliability in the practical case. Let's start from where the confusion will actually happen at work. Here's the story. During a project meeting to review the new module design, our team wanted to estimate the lifetime of the existing product as a benchmark. At the time, I was a reliability engineer, and I shared a Weibull plot saying the lifetime was 5.3 years. Then 3 leaders suddenly jumped out. They gave 3 different opinions. The first leader said, shouldn't lifetime mean 50% of failure, so it should be about just 5 years. And the second leader said, I think lifetime is when 37% of the population will fail, so it should be 4 years. And the third leader said, I saw a lot of field failures happen before 2 years, so how can you say the lifetime is more than 2 years? All of them look at the same data, but each of them sees something different. So, who is correct? Let's go ahead and find it out. Let's take a look at the Weibull plot together to find out the answer. Here is the Weibull plot. The x-axis is time in field, and the y-axis is the cumulative failure probability, and they all plot in the log scale. And this failure probability is calculated from the function here, where beta and eta are the Weibull distribution parameters. In our example, the Weibull curve has a shape parameter beta of 2 and a scale parameter eta of 6 years. So if you have 100 parts being built in the field from time 0, then after 2 years, the probability of failure can be calculated to be 10%, which means that 10 out of those 100 parts will fail after 2 years. The median life is when 50% of the population will fail, and it can be mathematically calculated by substituting ft with 50% and back calculate the time t. And it can also be read from the plot, where at 50%, the time here is around 5 years. Another concept is the characteristic life, or the Weibull scale parameter eta. It is when 63% of the population will fail, and it is true for all the Weibull plots. Why is that? That is because when t equals to eta, the ft is calculated to be a constant of 0.63. And in the plot, we see that when failure probability equals to 63%, time at x-axis is 6 years. And that is the same as our Weibull eta. The last concept I want to mention here is mean time to failure, or MTTF. It is the statistical average of the Weibull distribution, and it's calculated by the gamma function. In our example, it is about 5.3 years. So now we have the knowledge. Let's revisit those 3 questions. The first leader trying to correlate lifetime to 50% of the failure probability, so he was trying to use the median lifetime to represent the mean lifetime, which is not recommended. The second leader corresponds the characteristic life to 37% of the failure probability, so she mixed up the 37% failure probability with the 63% of the failure probability, which is not correct. And the third leader only focused on the early failure population, but he ignored the survivor population and the late failures, where his view is biased. So each of the 3 leaders tells us part of the story by just looking at different points on the same Weibull plot. Now that we understand what each parameter means, let's see how they work together to benchmark reliability. And remember, the Weibull distribution gives us 3 key metrics: beta, eta, and MTTF. Beta tells us the failure pattern, whether it is early failure, random failure, or wear-out failure, and it reflects the product maturity, where higher beta means fewer early failures. Eta tells us the scale of lifetime, from where we know the time when most products begin to wear out, and it reflects the product durability. Higher eta means longer lifetime. and MTTF combines the beta and eta, and it gives us the overall average lifetime. Together, these three numbers describe reliability in a complete and quantitative way. So back in our example, the reliability benchmark should include the beta equals to 2, eta equals to 6 years, and MTTF equals to 5.3 years. When you try to compare different versions at work in the next time, what you can do is to benchmark the reliability improvement by looking at whether beta increases, eta extends, or MTTF grows. And that is how Weibull turns from a theoretical plot into a practical reliability tool. And that's it. If you find the video useful, please don't forget to like and subscribe to Reliability Insider channel. Thank you.